Hey everybody, these 2-7 notes were looking kind of old, so I thought I'd go ahead and redo them for us. So 2-7, we're going to talk about absolute value functions, and the v in value is a very good indicator of what our graph is going to look like. Our graph's actually going to look like a v, and they are functions. They will pass the vertical line test, and your goal today is to be able to graph them without any problems. We're going to focus in on the things that have stars, not the things that have x's. If you need more practice, I'll be happy to go over the problems that have x's in class with you. So let's talk about our vocabulary. An absolute value function, f of x equals, very basically, the absolute value of x. Those are not ones, those are absolute value signs. It will take a shape of a v once it's graphed. The axis of symmetry is the line that the function is going to be mirrored around. So let's say right here, the axis of symmetry will be right there. It's an x equals line. It'll be x equals a number that your v will fold around. And what's this last one? The vertex is the middle point, I guess we could call it. Or it's like where it's reflective part of the graph. It's like where you fold it around. And it is going to exist on all absolute value functions. So this particular got it problem is just trying to say, like, you're jogging and it takes you across this county line. Suppose you graph it, your distance away from that county line that I just drew really poorly. So what's going to happen is this distance is going to decrease as you get closer. So let's say like right here, you are 3 units away from the county line. Well, when you're here as well, you're also another 3 units away from the county line. And when you're right here, you are 0 away from the county line. So if you were to graph that, it would be like a 3, and then a 0, and then a 3. So we're not talking about positives and negatives so much because absolute values don't. Absolute values only care about the magnitude of a number. So it's very similar to how you would say, well, you wouldn't say I'm -3 units away from the county line. You would just say 3 on either side of it. All right, so the very basic function is f of x equals absolute value of x. When there's no extra added numbers, when there's a 1 in the front and zeros all around it. It will always be on the right side of it, a very basic overline. It will always be a slope of 1 over 1 until I change it on you. And it will always start at 0, 0 as your vertex. And then the other side is going to be the reflective of that because it bounces up. Because let's say that this is your linear line. See it here? Absolute values always make things positive. So once you reach this point in here, you're negative, right? So the absolute value is going to take all that negativity and it's going to throw it in the positive area. And that's what this is. This is a piecewise function. They're saying that when x is greater than or equal to 0, you graph y equals x. But when it's less than 0, you graph y equals -x. Please don't get too stuck on that. As long as you know it's a V-shaped, and the xy chart looks just like this, because if you were to plug in -3 for x, you would get out +3. If you were to plug -2 in for x, you would get out +2. So it's just putting in the appropriate x's right here, and it's always going to be a positive number when you take the absolute value of it. Okay, let's graph it, and we're going to talk about a parent function and how it differs. We're going to use words like translating, up, down, left, right, stretch, compress, reflect. I'm sorry, kids must have just gotten out of lunch, so it's a little loud in that hallway. All right, the question is, how does y plus 4 equals the absolute value x? How does it compare to the parent function of just y equals the absolute value of x? Use an xy chart to graph it. And what is the axis of symmetry? So the first thing I want to point out is that y is not isolated, so we're going to do that first. And we're going to do that by subtracting 4. That's going to give us y equals the absolute value of x, and then the -4 in the back of it. You should remember from 2-6 that if we are comparing that to just the parent function of y equals absolute value of x, this -4 in the back is going to translate it down 4. I will create an XY chart for this one, and then I'm going to teach you eventually how to take a shortcut without an XY chart. All right? So there is nothing inside of here with X. See where I'm highlighting in orange right now? There's nothing inside of there with X being added or subtracted. So I'm going to put 0 in my middle and surround it. And then I will substitute those values of X into the function. So I'll do the absolute value of -2 minus 4 is really a positive 2 minus 4, which is really -2. I'm going to do the same thing now with positive 1. In fact, I'm going to be semi-lazy and just duplicate this a few times and erase my x's. Okay. So instead of plugging in -2 each time, I'm going to be plugging in my x values there. Maybe a little bit of a cheater there, huh? Okay, here I go. So the first thing we're going to do is plug in -1. That will give me 1 minus 4. There's Mr. Thomas. To get -3, now we'll put in 0. The absolute value of 0 minus 4 is really just 0 minus 4. The absolute value of 1 is 1 take away 4, -3. And then the absolute value of 2 is really 2 take away 4, and you get -2. Please notice these are reflective because the middle point 0, it hasn't moved left or right. Let's plot those points. So left 2 down 2, left 1 down 3, over 0 down 4, over 1 down 3, and there it is. There's that V shape taking form. There you go. That's how you graph an absolute value. You know, you could plug in more values of X if you wanted, but it's not needed. You should notice. There we go. That looks a little, well, good enough. You should notice that it did get translated down 4. And the last thing we need, so we did compare it. So when they asked us to compare it, here you go. When they asked us to compare it, that's this part here. And there's a lawnmower. And we used an XY chart. There's the XY chart. And now they want us to identify the axis of symmetry. So the axis of symmetry is where it folds around. See this X, see that little squiggle line right there? That is the line of X equals 0. That is the axis of symmetry. So I will highlight that in blue. I'm going to label it axis of symmetry. All right. Now, that can be a long and tedious method to graph these things using an XY chart. It certainly works, and I don't want you to think that it's wrong, but I am going to teach you a shortcut. But real quick, I'm hoping you guys know this +2 would mean up to, and that if you have a +k in the back, that moves it up or down, depending on what the value is. All right. Now, everything that we have learned from 2-6 still applies, okay? So if you have a number outside and in the back, that's still up. If it's a subtraction, that's down. We have learned that if the number in the front grows, that is a vertical stretch. We have learned that if the number in front shrinks, that is a vertical compression. We have learned that if there is a minus, a number inside with X, see inside, that's going to go to the right. And we have learned that if there's a plus number inside with X, that's going to go to the left. So none of that's new. And we have talked about reflection. If it goes from negative to positive or positive to negative, that is reflection. And now we're going to go ahead and apply those things. So problem 2. I do have an issue with problem 2 when I see it right away. It says which one's the correct graph. You see this 3? We need this 3 to be on the other side, because we want y to be isolated at all times. So let's add 3. Do not add it inside of here. This is a protected item, okay? So 2 is not going to turn into a 5. So we end up with y equals the absolute value of x plus 2, and then the plus 3 goes on the outside. Let's identify things we already know. A plus 2 on the inside is going to move it to the left. We learned that. And a plus 3 in the back is going to move it up. So which of these absolute value functions looks like it got from the origin, because remember originally at the very beginning of the lesson, the vertex was at the origin, which one moved to the left and up? Well, that's going to be option D, because it moved left 2, so it moved left 2 and up 3. So hopefully that'll be nice on multiple choice. You can kind of work it. Just make sure you get y by itself, okay? And we'll do this one. Does it have a star? Yeah. See how y is not isolated on this one? We need to move this entire unit to the other side. So we need to add the absolute value of x minus 2 to both sides. So that's going to give me a y equals, I ran out of room, so I'm going to do it here. The absolute value of x plus 2, or not plus 2, excuse me, minus 2. See how we added it to the other side? And then don't forget about that plus 1 that was in the back. Okay, here's the 1 if you're trying to figure it out. So that's going to go, let's see, what did we learn? Do you remember? A minus 2 on the inside is to the right. And do you remember what the 1 in the back? That's a positive, so it's going to go up 1. So let's look at which one looks like it moved to the right and up. Well, not this one. That one moved left. So that would be this one. Be careful. I did notice on a quiz once that kids are struggling if it's not counting by 1. So just look at your axes. Make sure you're using them appropriately. Here's right 2, up 1. All right. And let me get rid of that so it's not. There we go. All of this is for me to say I'm going to teach you a shortcut. Okay? And here's your shortcut. It's time for a shortcut to graphing these things. We are going to skip an XY chart for right now, although you can always use it. You just have to be careful when it moves left and right. Here's your shortcut. Step 1, no matter what, you have to solve for y, always. Then you're going to find what I call the vertex, and that vertex is found by taking the opposite of the inside and the exact number in the back. Then find your slope. It's the number in front of your absolute value. But you do need to be careful because you also have to, if there is a number in front of x, you have to pull it out. So I'm going to put asterisk if number in front of x, you have to pull it out. That's not going to happen very often, but I do want to make sure I at least reference that for when, if you see that somewhere in the homework, you can ask a little more about it. You'll plot the vertex and you'll make your slope, use your slope to graph the rest. So again, you can absolutely use an XY chart, but I'm really excited just to teach you a little shortcut here, okay? So what is the graph of 2y equals the absolute value of x? So step 1, we have to move this 2 to the other side. And remember, there is a 1 right here. So that's going to give me y equals the 1 divided by 2, and then the absolute value of x. Your vertex, as I indicated up here, your vertex is the opposite of the inside number and the exact number in the back. Now that's going to be hard for a couple of you, for at least at first, okay? We're going to get it though, I promise. All right. So what number is being added to x and what number is in the back? Hopefully both of those answers are 0. There is nothing being added or subtracted to x, and there is no number in the back. The slope is the number in front of the absolute value sign. So I'll highlight that in, I don't know, red. That's going to be that one. So the slope is 1 over 2. Remember, you do have to get y by itself, otherwise this whole, the whole shortcut doesn't work. Now the axis of symmetry is kind of a neat little item here. It will always be reflected around the x value of your vertex. So in this case, 0. It will always be reflected around the x value of your vertex. Now watch how we're going to graph this thing. First, we plot our vertex at 0, 0. I like to label it with a V. That way I know that right there, that's when it's going to start taking its shape. From your vertex, I will rise 1 and I will run 2. Rise 1, run 2. Rise 1, run 2. Do that a few times. I am going to connect this. Now remember, the way absolute values work is once they reach the vertex, they go the other way. They're not going to continue this path downhill because that's not how absolute values work. So we're going to rise 1, run 2 in the other direction. And if you make an XY chart, by all means go ahead. You will get out points like -4, 2. You will get out points like 6, 3. All right, and that's how that works if you use an XY chart. And your axis of symmetry, I think it's worth it to show you with a broken line, is right here. It's where you could fold it around, and it's that right there, and it would be the equation of x equals 0. Let's try again. Let's skip that one. All right, now we're going to apply all of the translations. Here it goes. First of all, and it does want us to compare it as well. So did I compare this one? I didn't. I apologize. Maybe that wasn't part of the directions, but here I do see here that I wanted to do the transformations. So if the parent function, unless it otherwise says, assume the parent function is just this, like absolute value of x, what's the only thing that's different? That 1/2 in the front, right? So the 1/2 is going to cause a vertical compression of 1/2. That's why it looks like the graph got stepped on. It looks like it's a little more wide. All right, now I'm going to go to the next part. So they want us to compare it, and we're also going to graph it, and we'll talk about our transformations. Here we go. So our vertex, let's start by graphing it. Please notice that y is already isolated. That should make you happy. So the vertex, as indicated up above, is opposite of this number, so +2, and the exact number in the back, 4. I'm going to erase that because it gets a little overwhelming, okay? So it is always opposite of this and exactly whatever this is. So opposite exactly. Okay, next thing. The slope is the number in the front of the absolute value. In this case, it would be a 3/1. So the number in the front, making it a fraction. The axis of symmetry will always be x equals the x value of the vertex. And we can do the transformations now, and then we'll see them visually, okay? So we need to assume that the parent function, oh, there it is right there. We're going to label that as the parent function. So we need to talk about the 3. So what does the 3 do to it? Well, since the 3 is greater than it used to be a 1, we're going to say it has a vertical stretch by a factor of 3. What does the -2 do to it? Well, since the -2 is inside, that is going to, and it's a minus, it's going to cause a movement to the right of 2. And we have a +4 in the back that we didn't used to have on the parent function. That +4 is in the back, so it's going to cause a movement of up 4. And now we're going to graph our absolute value function. So our vertex is at over 2, up 4. 1, 2, there it is. Over 2 and up 4. I'm going to put a V there because that's where it kind of changes. And my slope is up 3 from there. 1, 2, 3, and over 1. 1, 2, 3, over 1. I'm going to connect that side, but we're going to remember, we're not going to go straight down here. That's not how these ones work. They take, at the vertex, they take a turn, and they go up 3 and over 1 in the other direction. Up 3 over 1 in the other direction. That's how absolute values work. They change to positive once you hit your vertex. You could have made an XY chart, and you would have got any of those points there. I think it's good practice for us to also graph our axis of symmetry. So in this case, my axis of symmetry is x equals 2, which is right here. And sure enough, that's exactly where our absolute value function reflects around. Sorry, it was really messy. There you go. And that is the equation of x equals 2. All right, and sure, I'm hoping you can see that this does look like the graph has been stretched vertically. It's like kind of a tall, skinny graph. I'm hoping you can see it got moved to the right and then it got moved up. So you can see the transformations come alive. That, we're going to do it one more time, all right? I think we're doing pretty good on the time of this one. They want to know how it's transformed in the vertex, yada, yada. Okay, so here's our parent function, right? Our vertex is, do you remember? It's opposite of this number, so +1. And the number exactly in the back, -3. Get rid of that because it's a lot to look at. Our slope is the number in the front, so in this case, -2. Oh, make it a fraction. Our axis of symmetry is x equals the x value of the vertex. And our transformations, here's where we'll slow down, okay? The negative in the front, I'll make that pink. The negative in the front will cause it to be reflected. In other words, this thing's going to be upside down. The 2 in the front, because it used to be a 1 in the front, is a vertical stretch by a factor of 2. Some kids do get that mistaken. They think they put the negative with the 2, whereas remember, the negative is just a reflection. The -1 on the inside is going to be minus on the inside is right, that many units. And last, the -3 in the back is a down 3. And we should see all of that happen once we graph it. And I'm going to go ahead and graph it now. I will go over 1 and down 3. There it is. That's my point, my vertex. I'll label it with a V. And then I'm going to use my slope to go down 2 and right 1. Down 2 and right 1. That looks pretty good. Connect it, but don't go all the way, because remember, absolute values take a turn at their vertex. So instead of going down 2 and right, please go down 2 and left, down 2 and left, down 2 and left. And you can make an XY chart of this. There'd be nothing wrong with that. Your XY chart would prove the points that we're doing. I will also take the time to graph my axis of symmetry for good practice. That's going to be at x equals 1. Put my arrowheads on there. And there we go. We can call it a day. So there's our graph. I definitely do see that it's reflected. See how it's upside down? I see my vertical stretch of 2. I see that got moved to the right from the origin and down. And now again, if you wanted to make an XY chart, by all means, go ahead. If you're interested in what that XY chart would be, the only difference on these ones, because they're left and right, instead of putting 0 in the middle, you would have to put the opposite of this in the middle. So you would put a +1 in the middle, like that. That would help you see the beautiful reflection, okay? Again, on this one, if you wanted to make an XY chart instead of putting 0 in the middle, you would have to put a +2 in the middle and then like surround it. But if you don't want to make an XY chart, that's not a big deal. It's not something you absolutely have to do, especially if the shortcut works for you. That's all I got. I'll see you tomorrow.